Hello everyone. Today we're going to be going over LeetCode 1, or I think neetcode 3 or 4, twosome. So this is a very popular question. I wouldn't be surprised if you've ran into this once or twice. It's definitely the most popular problem from LeetCode, and it's one of the most basic ones. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. So indices, that just means the index of the two numbers that'll add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. And then we're given a few examples. There are some constraints. But we see through these examples, for example, example 1 says nums, this array contains 2, 7, 11, and 15, and the target is equal to 9. And the subarray that is, I guess, returned is the indices of 2 and 7 because they add up to 9. So that's why we return them. And the same thing can be said for example 2 and example 3. And yeah, so on the surface, this isn't a very hard problem. And if anything, you could really just set up, like I guess, two pointers in order to compare each and every single one. And that's what we're going to start to do for our brute force solution. So we'll go over it in a second. How we're going to set up our brute force solution in order to go through this array and find our indices to get our target value. So let's say we're given a specific array. Say it's 1, 2, and I guess 3. Doesn't really matter. For our brute force solution, what we're basically going to do is we're going to have two pointers. So our first pointer is going to be at the 0th element, and our second pointer will be whatever the element is plus 1. And it will go on until the end of the array. So it'll be set from, I guess, I to array, or I guess like length of nums, which is our array that we're given. So we'll have one pointer here, and we'll have the second pointer, and basically we'll see whether or not they add up to our target value. We'll just say our target value in this case is equal to 4. And we'll basically just go through this loop through this second pointer. So we'll compare, I guess, this value plus this. If it equals to target, then we can return, I guess, the indices of these two values. If not, we move on to the next element for our second pointer. And if 1 plus 3 is equal to the target, then we will return our indices subarray, which will be just 0, comma 2 in this case. And that would technically be our answer. So this really just includes two for loops, which have two pointers, one at I, which will be equal to, I guess, 0 in this case. And the second one, well, from I till the length of the array. And the second one, which will be from I plus 1 till the length of the array, which is all the way till the end. So let's take a look at what this would look like in code. So we'll just write down our brute force solution. Say for I in range length of nums. We will go through our second pointer for j in range of I plus 1 till length of nums. We'll say if nums of n is equal to nums of, nums of n. Nums of I is equal to nums of j, plus if these added is equal to target, then return I comma j. And then we can return a blank, I guess a blank array if there's no values that equal to target. Either that or if it's just one value. So we'll run that and see if it works. And yeah, there you go. Yeah, it works right here. So just as we talked about before, we have our first pointer, which is our I, and it's most likely not going to change. If it's something like 2, it'll just go through, I guess the second pointer will just go through the elements and see if it can equal to target. But we see here, for the output that's given here, the I would have to move over once in order to find this combination that will get us our target. And we see here it's not a very, our time complexity would be O of n squared, because we have to go through this array twice. One for the initial I pointer and another for the j pointer. And we basically have to go through this array more than necessary, honestly. There are a lot of tools that Python gives us that can help us to skip having to go through this array multiple times and optimize our O of n squared brute force solution. So let's go to the drawing board and take a look at what we could do to optimize this solution. All right, say we're given this array right here, and our target is 6. For our past solution, we would have to go through this entire array at least twice. One for one pointer, and I guess another for the other. So we'd have to go through the array twice. But in Python specifically, there are things called hash maps. And hash maps will basically help us to determine where our specific value that we're looking for is. So we would basically create a hash map for the indices, and it would basically contain both the element and the index it is attached to. So it would basically look like 1, 0, 2 is 1, 3 is 2, and 5 is 3. Whoops. And basically using this hash map that we have right here, I apologize for this spacing, it's not very good. And basically based on this dictionary that we have right here, we can easily be able to determine where the difference is between our current element and our difference. So it would basically look like this. We basically have a for loop after creating our first we'd have to create a for loop to create our dictionary or our hash map, and then we'd have to create another for loop after this for loop is done, obviously, where we would basically be at I, and we would say the difference is equal to target minus I, or n, I guess, either or. And basically we want to find this differential value. So we'll say like, well, we'll not say anything yet, but we basically want to find our like difference value in this hash map right here. So if our difference value is equal to, well, our target minus n is going to be 5. We can look in the hash map for 5. So we can get 5, and not only can we get 5, but we can get its index. And once we get its index, we can return the value of n, or at least the index of n, comma, and the index, we'll just say index for now, of the, I guess, difference value, which would be 5. And in this case, if we do this, then our, I guess, returned value will end up being 0, comma 3. And right here, we don't even have to go through the array multiple times. We don't have to brute force our way into the array multiple times. We just create a simple hash map, and then we basically check in that hash map where the difference value is. And based on where the difference value is and whether or not it's there, then we, I guess, take that, or we can, I guess, iterate through the array and or go to the next one and say it's 2, and then we would have to check for 2. And yeah, it's a lot more simpler, I guess. It's a lot more efficient compared to the brute force solution that we had, which just required 2 for loops, I guess a nested for loop, and having to go through the array multiple times. Whereas this is just like a lot more easier. We just make use of hash maps, which are very efficient, that we can use in Python, and we go from there. So let's take a look at what this would look like in code. So we could see here our brute force solution, where we had to use 2 for loops. And it's O of n squared. We're of course trying to optimize on that time complexity. As we said before, first we're going to start out with our, I guess, our hash map, which is, we're just going to call it indices because it's going to contain all the index, I guess, values of each element in the array. And our first loop is actually going to go towards this. So we're going to say for I and enumerate nums. And basically what enumerate means is basically it's going to give us an index value for each individual element in the array. So we'll say for I and then enumerate nums, we'll say indices n is equal to I. So this is basically going to say, I guess the value, or not not the key, but the value the key is assigned will be equal to the current index. So it'll be like example like 2 comma 0, like in this case. And once we've done this, this will basically create our indices hash map. And once we get our indices hash map, all we need to do is just, I guess, say the same thing as for I and in enumerate nums. We're going to say the difference is that which is the value we're trying to find in our hash map, going to be equal to target minus n. And then we'll say if the difference is in our original hash map, and also the element, or at least the index of this current element, does not equal to I, which is the current element's index. This is basically saying it's not the same. We're not at the same number, and we're not going to return the same element, just as it says right here. We'll say if difference is in indices and the indices diff, or at least the index of the difference value does not equal to I, if it's in there too. We'll say to return I, comma, indices diff. And this on its own should work. We're basically going through the array, trying to find whether or not the difference value is in our hash map. And if it is in our hash map, is it also this like not the same element that's being like used for the pointer? Then we'll return our value, or we'll return our subarray based on this. We'll go ahead and run this. And yeah, it works right here. So this is a lot more I guess not complex, but it's a lot more efficient compared to our brute force solution. And we'll say our time complexity for this will actually be O of n, which I think is the best time complexity you can get on this problem. So basically, we're just using hash maps in this problem to create a hash map for that creates like an element, or not an element, but an index for every single element in this array. And then we go through, we actually go through our array and say if if the difference, which is 9 minus 2 in this case, which is 7, is in the indices like our indices hash map, then we'll basically find the element of that. And if the element of that isn't the same as well, then we can return the subarray that we have gotten. And that's basically the logic that goes into this and helps it to work. So yeah, this is two-sum. It's not a very hard problem. It's very popular. It's one of the easier ones. It's a really good one to get you started for like beginners, you know. So yeah, this is basically my solution, and we're going to be going over more over the course of the next few months for neetcode and LeetCode as well, but just focusing on the neetcode 150 list. And yeah, we're going to continue, so stay on the lookout for that, and I'll see you next video.